one.
Hello, my name is Justin Wagner, and I'll be presenting the first portion of our project charter. Our project title is Express Coffee Locker System, and our authorization, this charter formally authorizes the initiation of temperature-sustaining Express Coffee Locker System project. The project manager has full authority to oversee design, develop, and the deployment phases, manage allocated resources, and ensure project success through completion. Project purpose and justification. The purpose of this project is to create an automatic locker system that preserves the temperature and quality of coffee and other refreshments until pickup. The system addresses inefficiencies in traditional coffee service models where drinks lose heat during delays or order backlogs. By integrating heated and cooled lockers with digital control systems, the innovation eliminates remakes, reduces operational waste, and enhances customer convenience. It offers a unique market advantage through speed, reliability, and modernized service integration for cafes and coffee retailers. Project objectives. Design and prototype a temperature-controlled locker system that maintains beverages at the same temperature until pickup. Bullet 2. Integrate LED indicators and digital access panels for real-time temperature monitoring and status visibility. Conduct cost-efficient production capped at $10,000 per unit. Secure patent protection and develop non-disclosure agreements with vendors and partners. Launch and evaluate the system across multiple outsourced retail locations within 6 months. Project scope description. The Express Coffee Locker System will include modular lockers units arranged in 3x3 or 4x4 configurations, with each unit equipped with stainless steel frames, durability and installation, heating and cooling modules for temperature control, ventilation fans for airflow stability, LED indicators, red heating, blue cooling, green ready, digital locks and displays integrated with mobile app technology for secure and efficient customer pickup. And that concludes my part of the presentation. I'll be followed by Quentin.
Here we go. That's perfect.
2 minutes and 50 seconds. So my name is Q. I will be doing the materials and components overview to our temperature sustaining coffee locker system. So the frame and body, the material is 304 grade stainless steel, and it's going to be food safe and corrosion resistant. It's going to be finished by a brush or matte for fingerprint resistance, so it stays clean. The outer shell can be made out of 304 grade stainless steel, corrosion resistant to heat and moisture. The inner layer is going to be 316 grade stainless steel, and it's more resistant to heat and moisture. The doors on it's going to be tempered glass so you can see through it, with silicone gasket for sealing, just to keep that temperature, cold and hot temperatures moderate. Temperature control, again, the stainless steel is going to be the gist of our locker system will be made out of. And the sensors for the digital thermostat for each compartment, so each locker will have its own thermostat where you keep the same temperature that you want it at. And control it to the Arduino or Raspberry Pi based system for precision control. Is basically our technology that's going to be inside the locker system. So whether you want it to be Bluetooth to your phone, where it could be in apps for like Starbucks apps, or PJ Coffee has an app as well. It's just so it can connect to your phone. Again, for our electronics, we're going to have a 7-inch touchscreen or LED indicators. This way it says order number 7 or Saturday, here's your order. It's in this locker. It's going to have a smart lock on it so people can't just go in your coffee shops and take whatever coffee they want. Of course, that's connected to Wi-Fi and Bluetooth. Again, we're going to be using phones. So yeah, we're going to need Wi-Fi and Bluetooth. And a power source, of course, is going to be powered as all this electronic. This is just how much watts and how much power.
It is now.
Alright, so LED indicator is going to be red for heating, blue for cooling, green for when it's ready. The moderate units is going to be a 3x3 or 4x4 layout. This is how big the actual locker is. It's going to be ventilation for fans for cooling modules so the locker doesn't get too overheated and we have stuff breaking down because it's too hot in the locker. The benefits is a superior temperature range and maintains hot or cold drinks for hours. It's going to be energy efficient, reduces workload on heating and cooling systems up to 40%. And it's going to be premium appearance. So for high-end coffee shops like Starbucks, it's going to look really nice. A summary, the stainless steel ensures durability and hygiene. It's going to be dual function for heating and cooling, maintains drink quality. The smart integration for seamless pickup process. So that means Starbucks is going to function a lot more efficiently when we have overload in the stores. And it's designed for Starbucks and local coffee shops. Assembly, this is how we're going to build our lockers. Of course, we're going to cut the stainless steels using CNC or laser cutting, and we have to weld or bolt those stainless steel pallets together to make a locker. It's going to be vacuum sealed air gap, and that minimizes heat transfer and conduction or convection. And it's going to ensure tight sealing for maximum temperature efficiency. We're going to have to attach this tempered glass with hinges or silicone gaskets, and of course, we're going to install the electronic smart locks on each compartment. Again, so people don't steal other people's coffees. There will be a mounted touchscreen and an LED panel for those red, blue, and green lights. There will have to be wiring that goes into these lockers. And of course, we're going to have Bluetooth and Wi-Fi also in these lockers. Each locker will be tested to see if the actual cools are heated. And it will be polished so that it also looks nice. The quality checks will be going through each of the lockers that we make sure they all function properly before they're up for sale. This is our cost breakdown. So the stainless steel is going to cost $2,800. The heat and cooling modules is going to be $1,500. Electronics, the LED, the panels, the touchscreen, all of that's going to be, and the locks, $2,200. The labor is going to take $1,800, give or take. The insulation and the brush, the matte finish, that would be $9. And testing that each of these lockers work would be $800 for a total of $10,000. Now this is for a 12-unit locker. So it would be 12 lockers. This is how much it would cost, $2,000. A summary is built with precision, and it's going to be very smart, it's going to be very efficient, and it's designed for commercial coffee shops. That's the end of my slide. We'll give it to Summer.
Okay. For this project, we are looking at the milestones that we're going to follow through. For month 1, we are going to be doing the project initiation and the patent filing. On month 2, we're going to be doing design finalizations and materials procurement. On month 3, we're going to be doing prototype construction and assembly with testing. On month 4, we're going to be doing solely testing and safety certifications, FDA approved, of course. On month 5 through 6, we're going to do pilot installation in partner stores, and that's where we're going to be working with our partners to see what it is that they're looking for and how this can function within their shop. On month 7, we will evaluate and do a market launch plan, and we will also be doing testing then too. The limitations and exclusions. Limitations would be available space in the coffee shop, the temperature control precision, and the maintenance outsourcing. Excludes beverage preparation or point of sale functions. The customer branding and advanced data analytics is not included in the initial pilot. And the initial rollout restricted to partner coffee shops in metropolitan areas. Our risk limits, our budget gap is $50,000 for prototype and patent filing. The scheduled risk is plus or minus every 2 weeks for variance tolerance. Our technical risks are managed through the third-party certifications and internal quality control. And the legal risk would be mitigated through patent filing and non-disclosure agreements on the people that would be working on the lockers themselves. The acceptance criteria, the lockers must maintain beverage temperature equal to or better than the store conditions. Pilot testing achieves 95% plus customer satisfaction when it comes to convenience and reliability. The store integration is seamless with no operational distribution. The team compositions that we would be using to launch this prototype, we would need a project manager to oversee scope, resources, and milestones. We would need a mechanical engineer to design the frame, installation, and heating and cooling systems. We would need an electrical engineer to develop the control circuits and LED interface. We would need a software developer who integrates the mobile app features, a quality specialist who conducts system performance and compliance tests, and then our marketing and operations lead, which coordinates pilot launch and outsourcing strategies. This charter authorizes the Express Coffee Locker System project to proceed through the design, development, and the pilot phases. And this is our design.